Hi, welcome to lesson 6.3, medians and altitudes of triangles. Now, in preparation for the lesson, please make sure that you have a few materials ready. You're going to need a couple of pieces of scratch paper, and you're going to need your compass and your protractor. So the first scratch paper, the first piece of blank paper goes on page 174. The second one goes on page 175. So put a half sheet of blank paper on page 175. Once you're ready, continue on with the video. On the next page, on page 176, you're going to put problem number 2 right there. And problem number 4 down here. Yes, the problems are going to be out of order, and it's going to be for a reason. Okay, and problem number 1 is going to go right here on page 177. All right, today we're going to learn 2 different centers of triangles. The first one that we are going to learn, and this is on page 174 of your journal, is the centroid. So far, we have learned about the circumcenter and the incenter. Today we're going to learn about the centroid and the orthocenter. So the centroid is made up of medians. Okay, so what exactly is a median? Because we haven't talked about this. A median is the segment. Okay, the segment, I should probably put it at the bottom. Okay, is the segment from the vertice to the midpoint. Okay, is a segment from the vertice to the midpoint across it. Huh? You'll see. All right, so what do you need? You need a triangle. Okay, so go ahead and do that. Do that triangle again. So here is my triangle. All right, I'm going to call my triangle ABC. Now, in order to get the median, we're going to pretend like we're going to do a perpendicular bisector, but we're not doing no perpendicular lines. Okay, I just want you to see that we're only going to do half of that construction. Pick 2 sides, doesn't matter which one. Okay, so from here, I'm going to open up to more than halfways. About so, right there. Okay. And I'm going to draw my 2 arcs like this. I'm going to do it from A, and I'm going to do it from B. Now, normally we would grab a ruler and go, boom, straight down to it. But we're not. Try to get the lighting to work. A little better. Okay. So then what you're going to do after this is you're going to line up your protractor, but you're not going to do the line. Okay, you're not doing the line. All you are doing is marking this point right there. That's it. Okay, and that point right there is the midpoint. Okay, that midpoint, what it does is that it breaks this into 2 congruent pieces. Now, what I'm going to do is I'm going to create a segment from the vertice to the midpoint across it. So from here to here. Boom. There's my first median. Okay. Repeat the process. All right. You can do it for A. You can do it for B. Doesn't matter. I'm going to do it for A and C. AC. Okay. So do a little bit more than halfways. Draw your arc from the left and to the right. Just try not to get lost with all of these guys. I know it's kind of hard. And you see, mine was too short, so I need to make mine a little longer here. Perfect. Okay, so like this. Once again, set these together. Don't do the line, just the side. Right there. And what this does, it does this one, and it does that one. So then what I'm going to do is I'm going to join my opposite vertice to that midpoint. Okay. And the point where they cross, that is called my centroid. I'm going to call this one D. Okay, so here, D is the centroid. So what does it do? Okay, well, I want you to notice one thing. Okay, I want you to notice this right here. What is the relationship between this right here? I'm going to call this, I don't know, E. What is the distance between DE compared to CD? How do they compare? Well, check this out. It's kind of cool, actually, if you think about it. Measure ED. How many of these can I fit into CD? 1, 2. Perfectly. Okay. So this means that ED is half of CD. There's different ways that you can interpret this. Okay. You can look at it as DE is half of the distance of CD, or you can look at it in terms of, 2 times the distance of DE equals CD. Like 2 of these equals 1 of these. You can look at it that way too. So how does each one compare to the whole side? Okay, well, here's this. If I can fit 2 of these in here, that means I can have 1, 2, 3. Okay, so DE is technically 1/3 of the whole segment CE. Okay, and CD happens to be 2/3 of the segment CE. So it all depends really how you want to look at it. I like to not look at it like this. I like to look at it in the sense that this is half of this. If I know this one, I can cut it in half and I can find this one. If I know this one, I can double it and get this one. If I know the whole thing, you know, I can divide it by 3 and find this distance and then double that to get this one. Okay, and this is true for this segment and this segment. Okay, this is half of this. Okay, or this is twice of this, and this is 1/3 of the whole thing, and this right here is 2/3 of the whole thing. Okay, so that's one thing that you guys have to remember about centroids. All right, let's take a look at the next construction, the Orthocenter. All right, Orthocenter. Orthocenter, it's kind of boring because it doesn't really do much, but it's good to know. Okay, so the Orthocenter is created from altitudes. Okay, it's created from altitudes. Okay, what is an altitude? Is the distance from a point perpendicular to its base. Okay, so let's draw one. Let's draw a triangle. So I'm going to create a triangle. Kind of like this. Okay, and I'm going to do the altitude. I'm going to call this triangle A, B, C. How do you draw an altitude? It's very, very simple. Okay, now I'm going to do my first altitude from B to segment AC. So I'm going to make my point be below that line, like this. I'm going to open up my compass, and because this is a big triangle, just open it up just a little bit past it. Okay, mine's probably a little bit more, about this much. So then draw an arc like this. Okay, you might want to close it in a little bit, just more, make sure it's more than halfway. And then draw an arc from that point right there and from this point right here. Now, what that's going to do is that's going to allow me to make a line from here to the opposite vertice. Right? And that's just going to be a perpendicular, not necessarily a perpendicular bisector. It's not going to cut this segment into half. Okay? That is an altitude. Now all I got to do is do it again for a different segment. So I'm going to do it for, I don't know, I'm going to do it for A. From A to BC. Okay, so I'm going to do the same thing again, a little bit past the line. Like this. Close it in a little bit. It's just got to be more than halfway. From there. And from there. And then you do it again. All right, so as you can see, this is where the altitudes cross. I'm going to call this one D. D is the Orthocenter. Okay? Whoops. It's the Orthocenter. It doesn't do anything. It's one of the boring ones because it doesn't do anything. It doesn't have anything fancy. The only thing that you guys do have to remember is that if you have different types of triangles, the Orthocenter is going to be in different locations. So if you have an acute triangle, like mine right now, the Orthocenter is going to be inside. If it's obtuse, the Orthocenter is going to be outside. Okay? And if it's a right triangle, the Orthocenter is going to be at the right angle. Not just on it, but at the right angle. All right. So let's go ahead and move on to the examples. Examples are actually pretty easy. All right, so let's take a look at the following examples. One of the things that I forgot to mention is that number 2 has a graph, so please make sure you put number 2 right on it, okay? So make sure you put number 2 right there, number 4 right there, and then number 1 right there. This one's on page 177. All right, so let's start with our very first example. Okay, so zoom in a little bit. It says point Q is the centroid. Okay, so remember what we said about the centroid. The centroid is part of the median, and it is 1/3 of the whole segment and half of this. So if SQ is equal to 8, remember that QW is equal to 1/2 of SQ. Okay, so all I got to do is literally substitute that in, and I get QW equal to 1/2 times 8, which is indeed 4. So QW is going to be 4. Takes care of that. SW is the sum of SQ and QW. So if this right here is 4, then SW is going to be 8 plus 4. So SW is going to equal to 12. That easy. If you know this one, then you know this one. And guys, the longest side is always going to be the one close to the vertice. The shortest side is going to be on the side of the side. And that's example number 1. Let's look at number 2. Okay, so on number 2, you have a graph. Okay, so let's graph it. Okay, 2, 1 is right there. 5, 8 is right here, and 8, 3 is right here. Okay, so you have R, S, and T. Now the question is, find the coordinates of the centroid. Now when you do this, you want to look at which one of these medians is going to allow you to easily find that. Because, you know, it's very complicated to do it for the ones that you can do it. So how do you figure it out? It's very simple. Take a look at this side. The midpoint is right here. Okay, so therefore, the median is going to lie on a horizontal or a vertical. If you look at the midpoint of ST, it's going to lie somewhere right here. It's going to be really hard to find where that 1/3 is going to be at. If you do it on this side, the midpoint is going to be about right there, and it'll be really difficult to figure it out. So the midpoint between these two, just visually, you can tell that it's right there. And it just so happens that it happens to be on a vertical. So where is the centroid going to be at? First off, let me highlight this part. The centroid is going to be 1/3 from the side. So you got to count. You have 1, 2, 3, 4, 5, 6. So the whole segment is 6, and 1/3 of that distance is 2. So you're going to count from here, 1, 2, and boom, there it is. Notice how this is 2 and this is 4. All right, so the centroid is going to be at 5, 4. That is where the centroid is going to be at. Okay? And that's example number 2. All right, example number 4. We have a proof. Okay? It says prove that the median from the vertex angle to the base of an isosceles triangle is an altitude. All right, so what you have here is that you have triangle ABC is isosceles with a base of AC, and BD is a median to the base. And they want me to prove that BD is an altitude. So in other words, I have to prove that this right here is going to be a right angle. All right, so check this out. It's not, it looks hard, but honestly, it is not. Okay, so first thing that you have is that this is an isosceles triangle. So I'm going to write up all this stuff right here. Okay, so first step. ABC is isosceles. Okay? ABC is isosceles with the base of AC. That's given. Okay. Also, they tell you that BD is an altitude. Okay. No, not an altitude. BD is a median. Okay. To base AC. That's given. All right, so let's expand on this. Okay, so what does it mean? Okay, because this is isosceles, you are going to have AB congruent to CB. Why? Because of the definition of an isosceles triangle. Okay, it's isosceles. Now, because it is a median, because BD is a median to AC, then that means that this is going to be a midpoint. Okay? So, therefore, AD is going to be congruent to CD. Okay. And the reason why is just simply definition of a median. All right. So now, I have a side and a side. I need another side, BD. BD is going to be congruent to itself. Why? Because of the reflexive property of congruence. Okay, here's your other side, which means now that the triangles are congruent. So triangle ADB is going to be congruent to triangle CDB. Why? The side-side-side congruence theorem. So what is that going to imply? That's going to imply that these two angles right here are congruent. So ADB is going to be congruent to angle CDB by CPCTC. Now, here's another thing. They are a linear pair. So if two angles are both congruent and a linear pair, then it's going to be a right triangle, or it's going to be a right angle. So angles ADB and angle CDB are right. I'm just going to put right. Okay. Why? Because they're not only are they congruent and a linear pair. So if they're right angles, that means that it's perpendicular. Okay, so therefore, in the last step, BD is going to be an altitude. Okay, by definition. Definition of an altitude. All right. I think I skipped one little step where I have to mention that they're perpendicular. But then again, this proof is long enough. All right. All right, make sure you have all your full set of notes. And if you have any questions, please feel free to ask. Have a great day.